This is problem number 5 from section 6.2. It asks us to find, it says one common type of a highway curve is a simple horizontal curve. It consists of two straight segments of highway connected by a portion of a circular arc with radius r as shown to the right. The distance d is called the external distance. Find the external distance d for a highway curve with r equals 689 and theta equals 49. So they want us to find, and it might be hard for you to see, they want us to find this distance right here, that's d. So they want us to find this distance. Now, they say, obviously, this is a part of a circle. So they're saying that this is the radius, this is the radius, and this is the radius. So all three of these are radiuses. So we can actually label all of these our radius, which is 689. So this is 689, this is 689, this is 689. Now remember, this middle 689 goes from here to here. So that doesn't give us D per se. They also tell us the angles are 49 degrees. So this angle here is 49 degrees, and this is 49 degrees. Now this problem gets real easy because if you notice they have the right triangle here. Well, if I find, using this right triangle, if I find the distance from this P to O, from P to O, if I find that distance, I can just subtract out the 689, which is the radius. That would tell me what D is. So let's draw that triangle right here. This is a right angle. We already know that this is 49 degrees. They tell us that this is D, right? So we're looking at this line, and this is 689 from here to here. And they tell us that this spot right here is also 689. Does that make sense? I think it should. So let's go ahead and try and solve this. So we're going to say that, and you can actually solve this two different ways. You can use this whole thing. So you can use this expression, D plus 689 for this side. Or you could just use x here. If you want to put x, find the whole side, and then subtract out the 689. I think for you guys, it would make sense to use x. So I'm going to call x this spot from there to there. Remember, x is just d plus 689, so it's the same idea. And let's go ahead and solve this. This would be the adjacent side of the angle. This is the opposite side. And this is the hypotenuse. So x is the hypotenuse. So I've got, let me write SOHCAHTOA. I'm going to slide down just a little bit. SOHCAHTOA at the top. And I've got the adjacent and the hypotenuse, which is what I'm going to use. So I need to use A and H, which is cosine. So I say cosine 49 equals 689 because of the adjacent side over my hypotenuse, which is x. Remember, that's from this spot all the way over here. Now I multiply here. X cosine 49 equals 689. And then I divide by that cosine 49. So I get 689 divided by cosine 49. I throw that in the calculator. 689 divided by cosine 49. That tells me I got 1050.2. I'll just write it as 50.2 feet. Now that's this long distance, right? So if I want to find D, I'm going to say that D equals this distance, so 1050.2 feet, minus the distance here, which is 689. Throw that in the calculator. So I like to use that second answer button. And it tells me I'm 361.2 feet. They tell us to round to the nearest foot. So that would be 361 feet.